See, here is a problem of integration. Okay, 0 to sine square x, and integrand is here is the sine inverse root t dt, plus 0 to cos square x, and the integrand is here is the cos inverse root t dt, and that is equal to pi by 2 1 pi by 4, and d is none of these. Okay, so see, for that let us assume as a g, and that is 0 to sine square x, and this is your sine inverse root t and dt, and then 0 to cos square x, cos inverse root t and dt. For that integral we have to let us assume and t is equal to that is a sine square theta. If we differentiate, dt is equal to sine theta into cos theta and d theta, so that is equal to sine theta and d theta. And for this integral, let t is equal to cos square alpha. This is dt is equal to minus 2 cos alpha and sin alpha, that is d alpha, minus sin 2 alpha and d alpha. Okay, and substitute in this integral. If 0, if we put here 0, then we get here for this zero sine square x. This is your t and this is your theta. 0 sine square x. If 0, put here 0, then we got 0. If t is sine square, then theta is x. Theta is x here. Okay. For that, t and alpha 0, and this is a cos square x. If 0, and this is a pi by 2. If cos square x, then alpha equal to x here. Okay. See, this is 0 to x, sine inverse root t. This is means sine theta. This is sine 2 theta and d theta, plus pi by 2 to x cos inverse root t. This is we get here cos alpha, and another is minus sin 2 alpha and d alpha. See, this is 0 to x, theta sin 2 theta d theta. This is a minus pi by 2 x alpha sin 2 alpha d alpha. 0 to x theta sine to theta. The property is between plus, then limit is interchange. That is x, and this is a pi by 2. This is alpha sine to alpha d alpha. The property is here a to b f of x dx. So b to a f of x and dx. Okay. So that's why you're doing here plus. And the another property is if a to b f of x dx, we can write here a to b f of x dx. If b lies between A and C, then A to C f of x and dx, that is A to B f of x dx, plus B to C f of x dx. Okay, so from that, this is 0 to x theta sine theta and d theta, that is x to pi by 2. We apply interchange as a theta, then theta sine to theta and d theta from this property. Okay, so now both the functions are looking same. So this is 0 to x and x to pi by 2, when x lies between 0 to pi by 2. So we can write here 0 to pi by 2. This is just theta and sine to theta and d theta. Integrate this as a u into v method. This is sine to theta and d theta. Theta sine to theta d theta minus, if we differentiate this we get here 1. If we integrate this we get here minus cos 2 theta by 2 and d theta, and this is equal to theta minus cos 2 theta by 2, minus minus plus. Again integrate this, is we get here sine 2 theta by 4 plus c. So this is the result. So we substitute here minus theta by 2 cos 2 theta 1 by 4 sine 2 theta 0 to pi by 2, and this is equal, if we put a pi by 2, then we get here minus pi by 4, and cos pi by 2, then cos pi is here minus 1. If we get put here pi by 2, then we get here sin pi is 0. If we put here 0, then the whole thing is 0, and this is also 0. So the answer is here pi by 4, the option C. Okay, this is the option C.